A hacking tool isn't some mythical artifact shrouded in secrecy or magic. It's just software, lines of code, designed for a specific security task, built by people with a purpose in mind. Think of it as a specialized wrench in a mechanic's toolkit, crafted to fit a particular bolt or solve a unique problem. Sometimes, off-the-shelf tools aren't enough. You need something custom, tailored for the job at hand. In cybersecurity, these tools are essential. They help professionals identify weaknesses, automate repetitive tasks, and reveal the hidden workings of complex systems, making sense of what's beneath the surface. Not all hacking tools are malicious. In fact, ethical hackers use them to test and secure networks, finding vulnerabilities before real attackers can exploit them. Researchers and hobbyists build tools to learn, to experiment, and to push the boundaries of what's possible in digital security. They share their discoveries, collaborate with others, and contribute to the ever-growing security community. Hacking tools come in all shapes and sizes, from simple scripts that check if a website is online, to advanced programs that analyze network traffic, uncover hidden data, or even attempt to crack tough encryption algorithms. Each tool is like a key, designed to unlock a specific digital lock or solve a particular puzzle in cyberspace. Their true power lies in automation, making the invisible visible, uncovering patterns, and revealing threats that would otherwise go unnoticed. With the right tools, a single person can test and secure vast, complex systems that would be impossible to check by hand. But with this power comes responsibility. Using these tools demands ethical intent, respect for privacy, and a commitment to doing what's right. Learning to build and use them is the first step to truly understanding network security, and to becoming a responsible defender of the digital world. It's about hands-on experience, getting your hands dirty, experimenting, and building something real from scratch. That's where your journey begins, with curiosity, creativity, and the drive to make technology safer for everyone. Python is the go-to language for security pros, ethical hackers, and penetration testers around the world. Its simplicity, readability, and rapid development cycle make it a favorite for anyone who needs to move fast and stay flexible. With Python's clean syntax, you can turn complex ideas into working tools in just hours or even minutes, an essential advantage in cybersecurity, where new threats and vulnerabilities appear every day. The standard library is packed with modules for networking, file handling, encryption, and data parsing, so you can build powerful, versatile tools right out of the box without hunting for extra downloads. And when you need specialized features, the Python Package Index, or PyPI, offers thousands of security-focused packages, like Scapy for packet crafting, requests for web interactions, and Beautiful Soup for web scraping, making it easy to extend your toolkit. Python scripts are cross-platform, running seamlessly on Windows, macOS, and Linux with little or no modification. This portability is crucial for hackers and security teams working in diverse environments or targeting different systems. The combination of simplicity, power, and portability makes Python the ideal foundation for hacking tools, penetration testing frameworks, and custom exploits. Whether you're just starting out or you're a seasoned professional, Python's gentle learning curve lets you focus on solving real-world problems, not wrestling with complicated syntax. That's why Python has become the backbone of modern security scripting, automation, and research. If you want to stay ahead in cybersecurity, start with Python, and you'll be ready for whatever comes next. A password generator is a simple but essential tool for creating strong, random passwords. Strong passwords are your first defense against breaches. Randomness is key. The tool pulls from uppercase, lowercase, numbers, and symbols, assembling them in unpredictable ways. Users choose the password length. Longer means stronger. The logic is straightforward. Define character sets, combine them, get user input for length, and randomly select characters. This project teaches you about strings, lists, user input, and randomness, core programming skills. You'll use Python's random module, a staple in security scripting. By building this, you're not just making a useful tool, you're learning how to solve real security problems with code. It's a foundational step on your journey. Start by importing Python's random and string modules, your main tools for randomness and character sets. Use string, ASCII, lowercase, string, ASCII, uppercase, string.digits, and a custom string for symbols to build your character pool. Combine these into one list or string for maximum flexibility. Prompt the user for the desired password length, converting their input to an integer and checking it's valid. The core loop for the chosen length, randomly picking characters from your pool using random.choice. Collect these characters in a list, then join them into a final password string. Print the password for the user. This approach is interactive, customizable, and secure. You've just built a practical tool and learned key Python concepts. That's real-world security scripting in action. Now let's build your very first offensive tool, a port scanner. This is a classic project in cybersecurity, and it's a great way to get hands-on experience with how attackers and defenders both view networks. Imagine a computer as a building with thousands of doors. These doors are called ports. Each port could be hiding a different service, like a web server or a file transfer tool, and sometimes even a vulnerability waiting to be discovered. A port scanner is like a digital locksmith. It checks which doors are open and which are locked, mapping out all the possible entry points into a system. This information is crucial for both attackers looking for weaknesses and defenders trying to secure their networks. Port scanning is fundamental for network reconnaissance and penetration testing. Security professionals use it to understand what services are exposed and to identify potential risks before attackers do. The scanner takes a target IP address and a range of ports from the user. It then systematically tries to connect to each port, one by one, to see which ones respond and which ones stay silent. Open ports mean active services are running and listening for connections. Closed ports are ignored, but sometimes even closed ports can reveal information about the system's configuration. This project introduces you to socket programming, which is the backbone of all network communication. Sockets allow computers to talk to each other over the internet or a local network. Python's socket module makes it easy to create connections, send requests, and interpret responses from remote machines. You'll see how just a few lines of code can reveal a lot about a network. By building a port scanner, you'll learn how computers communicate, how attackers find weaknesses, and how defenders can spot and fix vulnerabilities before they're exploited. It's a hands-on lesson in real-world security, giving you practical skills that are essential for anyone interested in cybersecurity or ethical hacking. Begin by importing Python's socket and sys modules. Socket for networking, sys for clean exits. Prompt the user for a target IP or host name and a port range. Use socket, getHost by name to resolve host names to IP addresses. Loop through the specified ports, creating a new socket for each. Use connectX to attempt a connection. A return value of 0 means the port is open. Print open ports as you find them, giving live feedback. Always close sockets after each attempt to free resources. When done, print a scan complete message. This script is flexible, interactive, and teaches you the basics of TCP/IP. You've just built a classic hacking tool from scratch. That's the power of Python and security. Every tool starts with a problem to solve, so plan before you code. Outline your tool's purpose, required inputs, and desired outputs. Set up your environment. Install Python and a good code editor like VS Code or PyCharm. Break your project into small, testable pieces. Get user input, process data, loop through actions. Test each part as you go. It makes debugging simple. When your script works, run it from the terminal with Python your script.py. Watch your idea come to life as a working tool. This process, plan, build, test, run, is the foundation of every great hacking script. The reward is seeing your creation in action. Building hacking tools comes with serious responsibility. The difference between ethical hacking and crime is intent and, above all, permission. Never use your tools on systems you don't own or lack explicit written consent to test. Legal consequences for unauthorized access are severe. Ethical hackers always operate within clear, agreed-upon boundaries. Limit your experiments to your own devices or dedicated test environments. The goal is to find and fix vulnerabilities, not exploit them. Use your skills to protect, not to harm. You've taken your first steps into cybersecurity, but this is just the beginning. The field evolves constantly. Commit to lifelong learning. Practice safely on platforms like Hack the Box or TryHackMe, designed for legal hacking. Study open source tools on GitHub. Read and modify real code to deepen your skills. Engage with the security community, share knowledge, and learn from others. Always keep your ethical compass. Use your skills to build and protect. The path of an ethical hacker is about curiosity, responsibility, and growth. Stay curious, keep building, and never stop learning. Your journey is just starting. Welcome to the world of ethical hacking.